Alright guys, welcome back to the another video. In this video, I'm going to talk about the custom data generator function which help to preprocess, normalize, standardize and augment my input dataset so that I can feed my dataset into the attention unit model and generate the plot mapping area. So let's get started. Alright, before starting the technical aspect of this video, I want to quickly recap on the previous video where I tell about like flood segmentation flowcharts so that we can generate the i- image segmentation based on the flooded region. So here I have the input data set and I have the custom data generator function, and the major work of this custom data generator function is to resize my image all to the 512 by 512 a size so that I can quickly fed into the model and then train and get the result. And also during that generation I can normalize or standardize my data set and do the data augmentation on the fly. And then the function my function should return the image in max batch so that I can easily fit into the model and then do the prediction. But before doing the technical aspect, let me discuss further more about custom data generator and what's the use of that custom data generator function and why I am trying to like do this method instead of like loading all the data set as a numpy array and then fed into the model. So the thing about that is it's very helpful during the image and max augmentation. Of course, I'm going to use the image data generator function from Tensorflow library, which is used to augment and preprocess the image. As I said, the data normalization standardized technique, and is it facilitate various data augmentation techniques such as rotating, shifting, flipping, and zooming. For example, in the below image, you can see original image and then rotated, flipped, and scaled and bright. We can also change the brightness uh, of the image as well. So yeah, so we can do this process inside our custom data generator function. And also there is the other way, like we can like either normalize or the standardize our image so that we can like enhance our image. uh, I have like created the different video for the image enhancement. If you haven't seen, you can see that video over here, or maybe while implementing you can see that process as well. And also it helped to solve the memory issue. What I mean is, like in the previous videos I try to load all the train x, test x, train y, text y values as a numpy matrix, but most frequently there is a like chance you will get this error unable to allocate 31.9 or the gb of an array with save the dot and data type float. So that means your memory ram is not sufficient to like store all the informations, all the like this much of like array shape into the memory, and then you get the memory issue. But with using like custom data generator function, it will only read the images of that batch and then try to feed into the model so that we never get that unable to allocate error. And also a little bit about like custom data generator the class. So I'll write the custom data generator class, which will be the Keras util sequence. Of course it will like produce the image batch and then the max batch, as you can see it in the get item here. So the thing is, inside this class I'll have the uh, init function, which is the constructor, and where I need to pass the location to the images and max batch, and then also the batch size, and shuffle whether you want to shuffle the data set or not. And based on this function, so it will just store all the like information into the class, and then after that we write some like data preprocessing script, I mean the methods such as like data augmentation, data normalization, or maybe data standardization. So we write these functions, and then after that this is the like key method you need to like highlight into the custom data generator function get item, which help to like generate the batches, and then so that we can pass that batch into the model. So the thing is, inside this function we'll like write the script to read the image and max pair, and then we call these methods like data augmentation and data normalization inside this function, and then produce the like batch of like, for example, if the batch size is 8 and my image style is 512 by 512 and RGB image, then my batch image size will be the 8 512 512 and 3 is the channel. And similarly for the batch max, I will my shape of that array will be 8 512 512 by 1. So instead of like reading all the image, which is like 3094 images at the same time, we are just loading 8. But don't worry about this array size, because in our actual case the array size will be different than here. Again, before diving into the coding section, I want to show you some of the like data set and the description about data. I am using the data set from Kaggle, so it's under this username, and don't worry, I'll share this link in the video description as well. And about this data set, so it is the like manual masking data set. There are only 290 images in max pairs. So this max were like prepared by the Label Studio software. You can test to do the like masking on your own like data set as well. And there are only like three files, I mean the three folders or file, whatever you say, the images and max, and then the metadata. And the interesting thing about this data set is like the model which I'm going to develop is like using only 290 set of data set, you can really you can generate the really good high accurate model. And based on that, like you can segment the flooded area from any kind of imagery. Uh, make sure the imagery should be the high resolution imagery. And also talking about data, actually if you are quite comfortable with the this data set, and if you want to do furthermore, then you can also try on sent1 to flood data set. So it's also the similar kind of data, but from Sentinel-1 into optical and radar imagery. So it has also like the tile dimension same, and number of sequence is 336, and there are lots of bands. And of course I'll provide this dataset link in the video description as well. And of course if you are like comfortable with the tutorial what I showed in the optical imagery, then you can, I highly recommend you to like try sent1 to flood dataset, and then try to create your own model as well. All right, so now it's time to write the code. But before starting, so I want to let you know that so I downloaded this data set and then uploaded it to my Google Drive. So I have images, and then if you see the images, it looks like these. So these are the like flooded area from like different area. I think those most of the imagery were I think it's from like Google, and I'm quite not sure about what are the actual source of imagery. And these are the binary marks showing whether it's flooded area or not. So and also there is like another CSV saying that it's metadata, so it has image and max pair, but I'm not going to use this CSV file for now. And yeah, so that's all about like my data set. So the first step in the tutorial will be like the imports. Of course we need to import the TensorFlow htf, and also I'm going to import OS, import numpy is np, and then I am also going to import the globe function, which help to like select the imagery and max pair. And the other thing is like I want to connect my Google Drive, so just click on this link and then it will connect the Google Drive. And before starting the tutorial, I want to show another update as well. So in the runtime, make sure to change your runtime type to GPU so that your process will be faster. But for now I'm okay with CPU because I'm not actually going to train my model. But yeah, I highly recommend you to select this option. I already tested this model several times. That's why I don't have the like time to like train my model on the GPU. So like I'm going to stay with CPU only for now. And yeah, this is my like dataset folder, and you can copy this path, and then you can images, your images will be globe.globe, and then okay, flooded, and then images I capital I image, and then and your images will be the I think they are JPG file, right? .jpg. And then your max will be the globe, and then same, and then mask, and I think it's png. All right, so if you type the lane images and then lane mask, then your length of the images, sorry, mask, it's only mask, okay, will be the same, which is 290. And but there is like a little bit problem on this method. So if you just write it like that, then your images and max pair won't be like matching with each other. So you need to like sort them so that they are sorted together, and then still you can get the same number. But that's like the way of like matching image with the corresponding mask. All right, so for the like using like custom data generator function, so I'm going to import other few things, so which are like numpy and cb2, which is helpful for the reading image in max pair. And I think I already loaded OS. And then also from TensorFlow Keras preprocessing image, and I'm going to import image data generator, which is the like which is the function, so that I can augment my images, and hit run. All right, so for the custom data generator, I'm going to copy and paste some code from the I wrote previously, and don't worry, I'm going to explain it here. So it's as I said in my presentation, it's the Keras sequence, and in the init, which is the constructor of this class, here I'm loading like images in max, and then the my batch size will be 8, and my image size will be 512 by 512, and I wrote shuffle equal to true, so that in each iteration we can like write we can like shuffle the data set. And I reassign those variable into the my class constructor. And here is I said in my presentation, so I have few functions. For example, to crop the random area from image, I have this random crop function. And I have also like data augmentation function, and I have length to find out the length of the each batch. And then data normalization function, data preprocessing function, which help to like resize or crop image. And then on each epoch function, so on each epoch we need to shuffle the data. That's why I'm writing this method. And in the get item, so I'll write the code to like actually get the data set and then load it into the RAM. So the for so this is the like basic model of our modality of our class. And of course in the get item, uh, I can start writing from the get item class. So in the get item, so first of all, we'll like write the start index and end index, since these functions should return us the batch of the images. So that's why I have start index is the index into self dot batch size, and the end index might be the minimum value of either the uh, next batch or the length of the imagery. So if your batch size is not like actually divided by the 8, so in that case the last batch might be the smaller number, not 8 comma 512 by 512 by 3, but the less. That's why I'm using the minimum function, which will be minimum. That will be the end index. And I'm here initializing the batch image and batch max. But I feel like before starting the writing this code, so I can start from top. So first of all, in the init function, so I need in the two things, so I'll copy and paste those things and then describe here. So the first thing is, on in each epoch we need to like, as I said, we need to shuffle the data set. That's why I call this function while like assigning this class, generating this class. And the self dot data gen, it's also the kind of method which help to like augment our data set. But of course if you have your own data augmentation technique, or if you want to implement the data augmentation technique that I discussed in the previous videos or the sections, then of course you can like simply ignore this and then write your own data augmentation technique. But I feel like this data generator function only work for the 3 channel RGB or RGBA image, not for the like multi-band image. But you can test it out and let me know in the comment section. And here I'm using like rotation range will be 5 degree, and then width shift and height shift will be 0.1. So my image is like it's 0.1, I think it's 0.1 pixel size. So my image is 512, and it will like the shift my image based on 0.1, either on left or right or top or down. And then my zoom range, whether zoom range is 0.05, or either it's zoom in or zoom out. And my horizontal and vertical flip is true. And these are the like major parameter here, I feel like, because the fill mode is constant. If the image is like, of course it will crop to the certain range. And for the other values we are using fill mode is the constant. By default it will be nearest neighbor fill mode, and cval will be 0. All right, so for the like random crop, so I'll also like copy and paste the code from my section. So here this function will randomly crop my images to the 512 by 512 size. Of course if it has the larger size, then it will try to like crop a different region on the image to 512 by 512 size. But of course, instead of this, if you have the larger image, you can write the function to like tile the images based on like some padding and then some stride. And instead of this, also you can use the like geotile package if you are dealing with uh, georeference dataset. And yeah, so it will try to like detect the some corner of xy point of the image, and based on that it try to like make the constant height and width 512 by 512, and then just crop the image. There is not much things to discuss. And for the data augmentation actually, so uh, I have this function over here, image data generator. Of course it will uh, create the image data set, but of course if you want to like augment the images, then you need to make sure that you are applying same parameter to the max image as well. That's why I'm using get random transformation function, and then apply that transformation parameter to both image and max and return image and max. And for the length Yalian method, so I'm using this function, so it will try to return the like the batch size. I mean the yeah, if it's length of the sequence, that means if it's 8 batch, then 290 images, then it will return the 290 by 8 and the int version of that image. And yeah, so that's length. And for the data now normalization actually, so I have some code over here. So okay, so for the data normalization, of course for the mask you need to reshape it into the 512 by 512 by 1. By default your max is 512 by 512, and I'm simply adding another channel 1. And then for the binary max, you can write whether if the max value is greater than 127, then it's 0, then it's 1, otherwise it's 0. So the thing from that data set is like the my image pair, my max pair has the 255 value for the is the flooded region. That's why I'm doing this process, so that I simply get it either 0 or 1. All right, and then it's returning image in max pair. And in the data preprocessing task actually, so I think I'm cropping my image. So okay, so I'm simply resizing my image to 576 by 576 size, and after that I'm cropping it randomly based on image and max pair. So that's the pre-processing step. And on each approach, as I said, I'm going to like write the shuffle function. So okay, so let me copy it and then paste it here. So the indexes, my indices will be the length of self images, the which is 290, and if shuffle equal to true, then I'm again shuffling my indexes. All right, so those are the like core methods. And after that, let me copy and paste some line of code in the get item page and then discuss it here. So of course get item should return the batch of like 8 images. That's why I'm iterating over 8 images. My indices, I'm selecting the start and end value, which will be 8 or less than 8 if it's the last index. And from here I'm like getting the image and max pair of that particular index, and I'm reading my image and max using OpenCV. Of course, if your dataset is georeference, then you can read it by raster or the geotile package. And if the image and max are like none, that means if the image and max are corrupted and cannot be read by CV2, then you are ignoring that image and then not using that image. And here I'm calling data preprocessing function, which will resize and randomly crop my data set over here, as I explained. And then data normalization, and then similarly data augmentation. And after that, to fix the issue during training process, I'm converting my max to the type as fluid, but this is completely optional. If you can train without the in the uint data type, then of course you don't need this step. And then I'm appending those image and max pair in the uh, batch images and batch max, and then I'm returning image in batch mask. So yeah, that's quite long, but yeah, it's not that difficult. So there are like multiple functions, multiple methods, so you can use those methods in the get item function. So the uh, major idea of about this custom data generator function is, instead of reading all the images at the same time and loading it into the memory, we are only reading the batch. So only reading the 8 images and 8 max tiles, so that we are saving our memory. All right, so that's pretty long, but that's all about this function. All right, so in order to get the dataset and visualize, I have this code. So I'm like using matplotlib.pyplot as plt, and then I'm reading the data from custom data generator, and I'm passing my image in max pair, which is over here. Sorry, here 290 images in max pair. And of course, by default, the batch size is 8, and then the number of shuffle is true. So yeah, I'm getting the batch image and batch max by the get item function. And I'm also like trying to get the random image, random number of, I mean, there are like 8 images inside batch, right? So I'm trying to get the random number, random index, and then try to initialize image in max pair, and then similarly like plotting those image in max pair from this function. So it's very helpful to determine whether your function is working correctly or not. So of course you can see, I think this image looks like it's uh, flipped vertically. That's why the buildings were on top and then the sky on the bottom. But yeah, looks like this is the water area, and then it's correctly like generating the result. And we can try for the view. All right, so yeah, this is the water body and this is also the water. So looks like it's getting right accurately. And yeah, looks like our custom data generator function is working fine. So yeah, so in this way you can like write your custom data generator function. Also you can write the visualization code inside the custom data generator. And if you found this helpful, then please hit the like button and subscribe to my channel. Thank you for watching.